Combine like terms. So when we combine like terms are objects that we can count together. So they must be the same algebraic parts. So we want to be able to show that things are different. So for example, x squared and x are different algebraic parts. They cannot be counted together. So if I have something that looks like this, if I want to draw this, I can show algebra tile drawing for this with x squareds. I can show two squares. Now in this case, I'm going to shade my positive one. So there's a positive x squared. That represents two positive x squareds. And then I have a positive x. So I'm going to round, maybe I'll just change colors here. That doesn't matter if you change colors or not. I'm just going to show that the x is different in shape. Now, since I shaded the positive x squareds, I should shade the positive x. And I'm going to show three of them, three of those objects. And we can see clearly with the algebra tiles that we cannot combine them because they are not like. Okay, they are different. For B, we have a negative x squared tile. So I'm just going to draw my x squared tile. And I'm not going to shade it in to show that it's negative. I'm going to have a positive x tile, which is a different shape. Okay, and I'm going to shade that in since it's positive. And then for the negative 4 ones, we have another shape that indicates as different than the other two shapes. So we have three different terms here. So that's going to be, I'm just going to zoom in a bit. There's my negative x tile, negative x tiles in here. So sorry, that's not negative x. My mistake, that's going to be negative 1. That's going to be a negative 1 tile, negative 1, negative 1, negative 1. Okay, so again, we can't combine terms because there are no like terms there. So for example 2, we need to identify pairs of like terms. Now, like terms are going to be when the variable parts and the powers all match. So here, really, I have xy squared. And it's easy to tell like terms when I write it like that. So in this case here, I ignore the -2 coefficient, and I can see that the variable parts are xy squared, so those two are a match. For number 2, I'm looking at, again, just the variable parts. I'm going to ignore the coefficient, so I'm looking for x squared y cubed, and I have x squared y cubed here, so again, I have a match. Here I just have the x, so I'm just looking for an x. The x divided by 5, that divide by 5 really is still just a coefficient. So there we have a match. For x squared y squared x, I'm going to rewrite that as x cubed y squared just to make it a little bit easier to look at. And I can see that I have a match here. There it is. Those two are a match. So we ignore the coefficient and we just look at the variable parts. The letters and the powers all have to match. In algebra, a really important part of algebra is being able to combine multiplication with addition or subtraction. And to combine multiplication, division with addition, subtraction, we need to distribute. So here I have two groups of whatever's inside the bracket. Well, that means I have 2 times x, or 2 x's. And I'm going to subtract 2 groups of 4, so I'm going to minus 8. I can show that by distribution. When we do distribution, we have to still remember that we're doing BEDMAS, so we cannot do 4 minus 3 first. That's a big no-no. Okay, so what we want to do first then is we need to do the multiplication. So when I multiply, especially when there's a negative, I want to make sure I distribute that negative. Now, before I do any distribution, I really should make sure that that 4 does not get touched. Okay, I can see if I have like terms afterwards, but that 4 should not be touched. Okay, till afterwards. So after I do the multiplication, I can then deal with that 4. But for now, I'm going to do the multiplication. So I get negative 3 times 2x. That means minus 6x's. I have negative 3 times minus y. Well, that's a double negative, so that should be plus. So I'm going to subtract 3 groups of negative y, which means I'm going to add 3 y's. And at this point, I have no like terms, so I have to just leave it like this. I'm not going to do 4 minus 6 because that 4 is counting ones. The 6 is counting x's. So same thing here. I don't do the plus first. Okay, that's a big no-no. I'm going to do the multiplication first. So that means that I need to keep track of that extra x. So I'm going to have x plus whatever happens with multiplication. So I'm going to multiply that out. So I'm going to end up with 2x times 4, which is 8x's, minus 2x times 3x. Well, numbers times numbers gives me 6. X times x gives me x squared. Here I do have like terms, so I can combine my like terms. I'm counting an x and 8 x's, so I have a total of 9 x's. The squareds get counted separately, so minus 6 x squareds. Here we've got lots of stuff going on, so we need to make sure that we distribute first. So I'm going to distribute. So 2 times 3 is 6. So I'm going to end up with 6. X times y is xy. 2x times x is 2x squared. Here I'm going to distribute the 3 y's. So I end up with 3xy minus 12y squared. And then plus x squared minus y squared. We deal with the plus and minuses after we deal with the multiplication. So here we have like terms. We have xy terms here and here. We have like terms of x squareds and x squareds. And I have like terms of y squared with y squared here. So for the xy terms, I'm going to count them up. I have a total of 9 xy terms. With the x terms, I have to remember that this is not just y, but not just not just 2x squared, but negative 2x squared. So with the x squareds, I have negative 2x squared plus x. That means I still have a negative 1x squared. And then lastly, with the y squareds, these are both negative y squared. So I have negative 12, negative 1. That gives me negative 13 y squareds. I don't have any more like terms, so I have to leave my answer like that.